This simple web application allows you to set a color for your profile picture with this color wheel picker, but it has a vulnerability and can be hacked. This is one of the challenges from the Sneak Fetch the Flag CTF competition that I co-hosted with Sneak this past weekend. Over on the challenges page, this is the color profile warm-ups challenge that had 143 solves by the end of the game. A little bit surprised it didn't have more. It is one of the warm-ups challenges, but the description here is use a beautiful color wheel to update your profile. We have a file to download, which should be the source code of the application. We can go ahead and download that now. And in the top right, we have a start button where we can go ahead and spin up a dynamic service or the container and instance for us to be able to interact with. This gives us an HTTP URL, just a link we can click to go play with the service. And here it is. This is our color picker, color profile, color wheel, where we can drag around and maybe update our profile. If I click this button, nothing really happens, but if I were to refresh the page after clicking our update profile, that should have saved that specific color for our profile. Now, what we want to do is actually kind of see what this is doing under the hood. We can hit F12 on our keyboard or just right-click and inspect element. Really, I want to go into the network tab of the developer tools in my web browser. I'll click over here and I will reload the page with just a simple refresh or clicking the button to reload here. Now, we get and retrieve the URL for our challenge, but if I actually click that update profile, you'll see that it sends another request over here. This is a simple post request. We can see the status code and the HTTP method here, just posting to /setColor. And if we actually dig into the request tab, we can see that, it actually sends our specific color over to the server. The response tab here just gives us, a JSON echo response of the profile color. But ultimately, we should dig in and see how this is actually happening based off the source code that we were just able to download. So I am inside of my Kali Linux virtual machine. I'll go ahead and hit Control-Alt-T on my keyboard to open up a terminal, F11 to mark that as full screen, and I have gone ahead and downloaded this, and I've stored it in a simple color profile directory in my temp location. Now, if I move into here, I've downloaded the color profile.zip as we saw, and simply extracted it with unzip and received all of these files. Now, I'll go ahead and open up everything inside of my text editor, Sublime Text, just opening up the period symbol for the whole directory here. I'll hit enter, and here we are. Now, on the left-hand side, you can see all of the specific files given in that folder, and let's dig in. Looks like Docker file is probably one of the most important to us because this is running as a Docker container, one of the instances that we just spun up on the server. I'll hit Control-Shift-P on my keyboard so that I can go ahead and set the syntax here just to get some color. I don't know, bash is honestly fine, just to display nice and easy. This is going to be a Node application, so it's running JavaScript, right? We set a working directory under the root of the file system, just simply color profile, and then we add a user, our app user, and then make the whole directory for /color profile owned by that app user. We switch context into that user and then copy in all of the packages, the dependencies, things that are necessary that we can install with NPM, the Node Package Manager. We'll bring in the server, we'll bring in the flag.txt file for this capture the flag competition, and all the views in the public directories here, and then expose port 3000 and simply run the server. So obviously, the server.js file is the most interesting part here, but we do have the package.json, by the way, that tells us a little bit more about the application. We can even see, the dependencies or the other libraries, external modules that are required for this application to run. Express, of course, being that sort of web server framework for Node in this application, and EJS, one of the templating languages for JavaScript and Node and Express. So we can assume that we probably, in our public location or the views, our index.ejs file is something that'll end up using some of this templating syntax. And you can see here's all the HTML, just regular returned by our web browser, but let's keep an eye out for all of the EJS syntax or that server-side sort of templating stuff that might be in the mix. We can even see, we reference a client.js for the JavaScript here, and there's even some inline or kind of embedded JavaScript as well. We grab the initial color Okay, that's seemingly presented by our EJS, that templating language, and then we use some functions, probably in client.js, to invert that color. So we can, change the background or update the actual background color or anything that we might use for the text on the page. That's just to add a little bit of pizzazz, make it look like, ooh, the web page has some functionality to it. But ultimately, I do want to be keeping an eye out for those server-side pieces of code here, because maybe those are things that I could tamper with or manipulate as, hey, the budding hacker or ethical hacker trying to find a vulnerability for this application. I do see another one interesting here, profile color, again, with sort of the less than arrows or greater than symbols to denote maybe that's a variable being passed in by the templating module. But notice something peculiar here. They use an equal sign to denote this, and they don't here. So an oddity, maybe just something to keep in mind, or maybe there are some tricks up its sleeve. Let's look at the client.js script. This is the JavaScript, and simple, small stuff. Okay, maybe just a handler to deal with, clicking the submit color button. That is likely just going to post to set color, that endpoint as we just saw, and then, manipulate what HTML element colors we'd like here. And a convenience function to invert the color, but that's not all that interesting. It uses a template string, which maybe could have some things we could tamper with, but all of these look like static values, just numbers, nothing that we have control over as a user or attacker. We could, if we wanted to, take a look at the whole node modules folder and directory that actually has all the dependencies, built-in requirements and modules here, but these all probably rely on something else that rely on something else, so you get this nested dependency mess that is, node and npm modules. So let's put that away. Let's dig into the rest here. But let me tell you, there is a little bit of a nudge where we say, hey, Sneak can help solve this challenge. Go ahead and try out using Sneak, given the source code. Hey, you're doing some white box testing. Ooh, you have the whole application here. You might be able to see where are the vulnerabilities. Hey, if I may say, this is the benefit of using Sneak. It can do its static code analysis and try to find security vulnerabilities just given the source code and see what could it track down, either in the code itself or containers or infrastructure as code, all the stuff that Sneak could dig into. I'll get back in the command line and I could honestly just run like Sneak code test in this exact same directory where all of the source code is. But hey, I'll be honest, Sneak is like so good at tracking down all the different dependencies and their issues and corners and crevices of other packages that it relies on, where it might be able to find, some low vulnerabilities based off of something somewhere embedded way into some of the modules. But honestly, it didn't seem to track down what I thought would have been the vulnerability that is most clearly observed here. Because if we get back to the source code and we finally dig into the server.js file, the whole backend logic for this application, we see everything that we load in for Node. Hey, we need Express, we need body parser, we need path, file system, and of course, EJS. We set that view engine, our templating language, to EJS. We start to statically serve files for our client-side JavaScript code, and we handle a bunch of this with our set color handler. But here's the gimmick. We go ahead and actually read from the file system the contents of our index.js script internally. Like we slurp up the entire contents of that file, pull it into memory, and then say, okay, can we retrieve this contents and then pull the data out of it? If there's an error, then hey, we return just an internal server error, HTTP code 500, something went horribly wrong. But we actually take the data and then we replace that profile color that was wrapped in the less than and greater than symbols and percent sign here, and then we just put in place the profile.color variable that we're tracking internally server side. Now, I don't know if you're tracking, but that is not normally how you use some templating libraries, things like Jinja and maybe that Python Flask world or Django, right? Now, you've probably seen others like handlebars or mustache or pug, but EJS is really all just working the same. The thing is, oftentimes you give like a render template function that will just take a path to the file and then do the templating as it should with its own library capabilities. We have sort of manually and sort of hand jammed in, hey, replacing the contents of a placeholder that we set for our variable rather than using the templating language as it's meant to be used. It still ends up using rendered HTML with ejs.render, but that really means that, okay, we could manipulate our profile.color variable to be syntax that EJS, like our templating language, would then evaluate and actually execute. We could preemptively, like, manipulate, tamper with, and almost sort of poison or inject into our server-side templating. That is server-side template injection. So you know what? We can play with this. Let's create a new file. Let's make our own script. Like, I like to do this in Python. I'm sure you could use Burp Suite or Postman or whatever HTTP sort of in the middle proxy, but I just like to use Python because we can, hey, fire it up as we want on demand. Let me save a playground.py script. Let's add a shebang line, user bin environment Python 3. Just the usual boilerplate code to be able to get a script in action here. Let me import the requests module so I can interact with HTTP services, like online stuff here. And let's set a URL variable that'll actually reach our specific instance here. This is our, hey, challenge.ctf.games given the port. Let's copy and paste that and slap it in here. I'll go ahead and remove that trailing forward slash because ultimately we want to go to that /set color endpoint, right? Let's define our own session the way, hey, maybe requests can give us an object where we'll actually interact with that page. And sure, we can session.close at the end or use some with context manager or whatever. But ultimately, we will do a session.post to that same URL, but appending on and adding in the set color endpoint, right? Now we need to pass in some specific data. We need to say, ooh, that data can be maybe our color variable, and just for testing's sake, I don't know, let's make the whole thing black. Let's do the octothorpe or hashtag to denote a real color, and let's do 00000000000, many zeros, right? Let's store that as a variable. We'll say r can equal that. So we could simply print out the r.text or the response of that post message. Can I get this to run? Let me hit Control B on my keyboard to invoke this from the command line, or within Sublime Text, sorry, and just like that. Okay, it returns and echoes out our profile color. Now, we could do some interesting stuff. Let's hop back to the application here. If I were to actually hit F5 or refresh, Control-Shift-R, the whole thing's black, right? We've set the actual color to what we want. We could manipulate it one way or another, but this is the injection point for our server-side template injection. Now, we know that we want to do something with the language here, but if this is a variable just kind of being evaluated, let's poke around and play. Can I just change this to, like, I don't know, 7 plus 7? If I hit Control B on my keyboard, does that return 14? No, it just gives me the string. Okay. What if I tried to wrap that in some of the specific syntax that EJS might want to process and evaluate? Like, hey, that greater than, less than symbols and percent signs, will that actually execute? Let me hit Control B again. Not quite. Okay, what about an equal sign at the end there? That, I think, might mean, oh, evaluate this. Let's try that. Maybe that minus symbol will tell EJS, hey, interpret this literally? Control B on that? No. Well, actually, let's not forget, because what the endpoint responds is actually not where we're seeing the potential server-side template injection, because we only ended up manipulating, considering the server-side code, the profile color that did not have some minus sign or equal sign or other syntax for EJS. That was only specified in our index inside of this little placeholder, right inside the HTML. You can see this block here. This is presumably the only place that gets modified. So maybe we need to go see that on the web page. Let me go back to the web browser. Let's hit F5 to refresh the page here. And this display out here isn't really that helpful for us. But if I hit Control U, can I actually see, ooh, now I'm looking at the source code, like HTML, the raw response of the web page. Look at that value. That is 14. That's 7 plus 7. So let's tweak our script. Maybe we can retrieve this same page one more time after we've sent a payload, so to speak, and try to carve out this data.js color section. I don't know, that's fine. Let's go back to our playground.py. And rather than returning, oh, the response of the post request, let's make another request where we actually go get the URL. Now we print out our r.text. That's the whole response of just the web page. But could I go ahead and split this based off of that data.js color nonsense? Let's try to remove the inner value of the double quotes. And then everything that follows that beginning syntax is everything after the double quote, right? So I'm going to index that at 1, because normally Python lists start index based off of 0, which means I could split this again based off of just the double quote, and then get the part in front of it based off of index 0. Does that kind of make sense? Let's see if I can store that as a variable called value, and I'll simply print off that value. Try it out, Control B. Ooh, value is equal to 14, just as we saw. Now I can manipulate this, right? Let's try to change our plus sign to just an asterisk, maybe do some multiplication, kind of validate that we're doing what we think we're doing. Control B to run again. Value is 49. So that is working just as it should. Now, we need a payload that could do anything. We know that we're executing potentially code in the context of the server, the backend Node and Express web application. We're hacking into this thing. Ultimately, our goal is to find the flag, right? Given the Docker file, that flag is in the same current directory. So could I actually get some syntax where I could use node and actually climb up, I don't know, what's method resolution order, try to call some specific functions, maybe use any of the code already present in the context of the server, and then read the flag file in the current working directory. Let's go try it out. We could try to use something like that FS module, like the file system, right? Or we could Google. Let's just, hey, ask Uncle Google, maybe ask ChatGPT, you know, Auntie GPT. Say, hey, give me some syntax or a payload where I could read a file with Node and the FS module. Let's do it. Let's go to google.com. I'm going to simply search for NodeJS, read a file, FS module, and let's see if we can get the syntax. Oh, here's the Node.js documentation for fs.read file. Looks like there's a whole lot of these. This is the whole documentation. Can I look for read file? Oh, and they have read file sync, which we can assume, you know, given, you know, JavaScript and Express and Node and all of its sort of like promises and asynchronous code operations, a read file sync for like synchronous, probably, yeah, we'll just straight up return the contents of the file. So could I simply use fs.readFileSync and maybe pull that out? Let's try in our syntax here, fs.readFileSync, given the file name that we know that we're looking for, that is simply flag.txt. Can I hit Control B to run that? Oh, no, it has an error. Connection error, remote end close, connection without response. Does it not know that FS syntax? Let's go back to Googling so we can kind of keep learning here. Let's do Node.js read file server side template injection. Can we get any payloads for this? A lot of stuff on hack tricks, a lot of stuff in payloads, all the things. Here's one of my videos. Appreciate that. Let's take a look at hack tricks. And actually, hack tricks, you know, put together by Carlos Polup and some of the great research he's been doing. We actually had one of the really cool challenges in the Sneak Fetch the Flag competition with him and a good friend. That was the off the set UID binary. Only one team solved it. It was crazy cool. Anyway, let's try to see, hey, can we find anything? Let me Control F for like EJS. Is that present? No. Okay, but we do have a lot of stuff for Node, JS render, pug, etc. Oh, and they do something interesting here. I don't know if you can see some of the syntax examples, but they actually load different things from global process main module. Global process main module lets us sort of climb the context of the application and like Node and express as we're running it here. So I wonder if we could sort of use that as the object to grab the file system or FS module. We could use global.process.main module, maybe dot, rather than constructor, we could even honestly just like call require, like the same way that you might use for a module. Think of it as like the underscore import underscore in Python. If you're using like, oh, it as a function call to pull in a new module. Let's try that. Let's kind of manipulate our payload here where I'll actually use global.process main module, and then let me try to .require given our FS object that we want from it. That will sort of climb up and retrieve, oh, the file system object, and then from that, given its context, we'll use the .readFileSync function to grab the flag.txt. Let's hit Control B to try to run this. Ooh, it got it. Look at that. Just like that, we retrieve the flag by climbing up sort of, oh, the main module of our Node application. And with this, we could really run whatever we want, or like we could try to read any file we want, like etc password or etc hosts or any arbitrary file that we might want here. I'll hit Control B and take a look. Here is our giant etc password file that we've just pulled out. Or we could try to get code execution. I don't know, maybe we could load a whole nother library potentially. Like if we look at some of the other syntax examples from this server-side template injection, maybe we could actually use the main module to require like child process and then execute different things. Or like, ooh, spawn sync. I think that's the one that we want here. Can I spawn sync like the whoami or ID command? We're using that syntax again with our EJS handler for our server-side template injection, but let's look for child process as the library module that we want to pull in, and let's use spawn sync. Maybe we could run ID. Will that work? I'll hit Control B. Ooh, we have an object. We have an object. Yeah, I think the .standard out property or variable there is really the output of the command. So with that, we're simply running the ID command. Can we get that to work? Yeah. Okay, so we have full code execution. If you wanted to, you could get a complete reverse shell on this. So hey, if you wanted to, we could clean up our script. I don't know, maybe make a payload variable, and we could store that as whatever we want. Now, nice and easy, we have our own solve script, something that we could use over and over and over again to always retrieve the flag, or just to easily mess with this and keep tinkering and troubleshooting. And honestly, I think that Python is a little bit better and faster and easier for prototyping than like Burp Suite or Postman. But hey, you get to choose what tools you want to use, and you get to see how you can beat up these challenges. And that was all the fun of the Sneak Fetch the Flag. Now that we solved that challenge, hey, we can submit the flag and get some new points up on the scoreboard. With that, that is the color profile challenge, just some server-side template injection. And look, I hope you played, I hope you had fun, hope you learned something with the Sneak Fetch the Flag CTF, and maybe you did get to kick the tires on Sneak while you got to try your hand at some of the challenges. See, what could it uncover for different vulnerabilities? If that sounds interesting to you, like, ooh, maybe how many vulnerabilities are in your own code or projects or applications that you're working on, give Sneak a try. There's a link in the video description. Hey, I hope you're having a whole lot of fun with it. Thanks for watching, everyone. I'll see you in the next video.